Let's take a look at dividing polynomials and synthetic division. And let's take a look at our first example. We've got 5x to the fourth minus 15x squared over 5x squared. Now these first ones specifically, we have a single term in the denominator. Now it doesn't have to be a term, but if you have a single something, like if you go on and take trig, you may have a single trig function down there, a single trig expression. Basically, you don't have pluses or minuses in there, with it separating two items. For division here, if we got a single term, what we're going to do is we're going to take each term up on top and put it over that term. So we got 5x to the fourth over 5x squared minus 15x squared over 5x squared. Then we want to do a little bit of simplifying. The 5's cancel here. Here we have x to the fourth, and here we have x squared. If you have x to the power over x to the power, you subtract the exponents over on the side. So 4 minus 2 gives me 2, and we have x to that power where a larger one was. The larger exponent was up on top. So we're going to be left with an x squared up there. And then 1 here. Minus 15 and 5 both divisible by 5. 15 divided by 5 is 3. 5 divided by 5 is 1. And these x squareds are the same, so they cancel away. So we're going to have x squared minus 3. And that's our answer. Let's take a look at another one with a single term. We've got 2x to the third, y to the fourth, minus 3x squared, y to the third, minus 5xy over 4x squared, y squared. Double check all that. Okay, looks right. Again, we have a single term down in the denominator, so we want to split this up into separate fractions. We've got 3 terms up on top, so we'll have 3 fractions. So we're going to have 2x to the third, y to the fourth, over 4x squared, y squared, minus 3x squared, y to the third, over 4x squared, y squared, minus 5xy over 4x squared, y squared. Okay, number-wise, 2 and 4, those are both divisible by 2. 2 divided by 2 is 1. 4 divided by 2 is 2. Here we have x to a power over x to a power. Again, I subtract the exponents. 3 minus 2 gives me 1, and we have x to the first power where the larger exponent was, which was up on top. Now here we have y to a power over y to a power. Again, we subtract the exponents. 4 minus 2 gives me 2, and we have y to the second power where the larger exponent was, which was up top. Minus, and 3 and 4 I can't reduce any. Now these x squareds are the same, so they're just going to cancel. Here we have y to a power over y to a power. Again, you subtract the exponents. 3 minus 2 gives you 1, and you have y to the first power where your larger exponent was, which was up on top. Minus, and can't do anything with these numbers. Now here we have x, and if you just have x, that's like the first power. So if I were to put a power on them, this would be the first power, and this would be the first power. So we got x to a power over x to a power. We're going to subtract the exponents, smaller from larger. 2 minus 1 gives us 1, and we're going to have x to the first power where the larger exponent was, which was on the bottom. Now here we have y to a power over y to a power. Again, I'm going to subtract the smaller exponent from the larger one. 2 minus 1 gives us 1, and we have y to the first power where the larger one was, which was on the bottom. Which gives us x y squared over 2 minus 3y over 4 minus 5 over 4xy. And that's our answer. Now, typically, simplified form in math means get a single fraction. So it doesn't always seem like it makes sense, like, well, why do you do this? Well, this is more of a calculus concept. If you're going on to business calc or calc 1, this is a technique you have to use to solve some of the problems. Now, the next problem is different. We have x squared minus 10x plus 16 all over x minus 2. And it says divide using long division. Well, even if it didn't say that, we don't have a single term down in the denominator anymore. So we can't split them into separate fractions. So we have to use, there's two methods we could use on this one, but specifically it says use long division, polynomial division. Well, before I do that, let's refresh our memory on long division. Let's look at this problem. Now we take a look at the 11. 11 doesn't go into 3, but it goes into 30. You ask yourself, what times 11 either gives you 30 or as close as you can get to 30? Well, that's 2. Now remember, whatever you put up on top here, you multiply by what's out in front. 2 times 11 is 22. Now in class, I say, okay, now we add these together and we get 52. And they said, no, you all messed up. We subtract that. And I say, well, what do you mean? This is a positive 22. Basically, what we do is we flip the sign of it. So we put a negative before it. So 30 and a negative 22 gives us 8, or 30 minus 22. Key thing to remember here is we flip the sign. This was a positive 22. And then I'll bring down all the rest. Depending upon who taught you division, they either told you to leave it up there or bring it down. Okay, now keep those steps in mind. It's exact same steps over here. It's actually a little bit easier. Now in deciding what goes up on top, we only look at the first term of each. So I'll look at the x and I'll look at the x squared. And it's not how close can you get, it's always exact. So you ask yourself, what times x gives you x squared? And that would be x. Well, remember what we did over here. The 2 we put up here, whatever we put up on top, we multiplied by what was out in front. We took 2 times 11. Well, that's what we're going to do over here. Whatever we put up on top, we'll multiply by what's out in front. So we'll take x times x minus 2. X times x is x squared. X times negative 2 is negative 2x. And we'll put that here. Now remember what we did here. We had a positive 22, we made it a negative 22. Basically we subtracted that. And whenever you subtract something, it flips the signs. But the key thing to remember here is we're going to flip the signs. We're subtracting this x squared minus 2x, we'll flip the signs. So this becomes negative and this becomes positive. Now a lot of people do this in their head, but I can't show you steps in my head very well, so I'll always flip the signs right on the problem here. X squared minus x squared drops away. Negative 10x plus 2x gives us negative 8x. And I was taught to bring everything down, so I'll go ahead and bring down the plus 16. Well, then we continue our process. I didn't do it over here, but we continue. We ask ourselves what times x gives us negative 8x, and that's negative 8. Now remember, whatever you put up on top, you multiply by what's out in front. So we're going to take negative 8 times x minus 2. Negative 8 times x is negative 8x. Negative 8 times negative 2 is a positive 16. So we got negative 8x plus 16. We're going to subtract that line, which means we'll flip the sign. So this negative 8x becomes positive. This positive 16 becomes negative. Negative 8x plus 8x drops away. 16 minus 16 gives us 0. So our answer for this problem is x minus 8, whatever we have on top here. I'm pretty sure I have these pages saved, but let me double check. Okay. Dividing polynomials. Okay. Page. And slow. There it goes. I guess I do have it saved. Let's take a look at another long division one. Let me grab a drink. Got x to the third minus x squared minus 11x plus 3 divided by x plus 3. Okay, let's set up into our long division form. There we go. Now again, we look at the first term of each, decide what to put up on top. So you ask yourself, what times x gives you x to the third, and that'd be x squared. Now whatever you put up on top, you multiply by what's out in front. So we're going to take the x squared times x plus 3. X squared times x is x to the third. X squared times 3 is 3x squared. So we've got x to the third plus 3x squared. We're going to subtract this line, which means we'll flip the signs. So this x to the third becomes negative. This 3x squared becomes negative. Well, x to the third minus x to the third drops away. Negative x squared minus 3x squared gives us negative 4x squared. And I'll go ahead and bring everything else down. So we've got minus 11x plus 3. Excuse me. Now again, we look at the first term of each, decide what to put up on top. We ask ourselves, what times x gives you negative 4x squared? And that'd be negative 4x. Whatever you put up on top, you multiply by what's on front. So we're going to take negative 4x times x plus 3. Negative 4x times x is negative 4x squared. Negative 4x times 3 is negative 12x. There we go. We're going to subtract that line, which means flip signs. So this negative becomes positive, this negative becomes positive. Negative 4x squared plus 4x squared drops away. Negative 11x plus 12x gives us positive 1x, or just x. And I'll bring down the 3. Again, we look at the first term of each, decide what to put up on top. You ask yourself, what times x gives you x? And that'd be 1. Now, whatever you put up on top, you multiply by what's out in front. So we're going to take 1 times x plus 3. 1 times x is x. 1 times 3 is 3. Put that here, and then we're going to subtract that line. So we'll flip signs. So the positive x becomes negative, the positive 3 becomes negative. X minus x drops away, 3 minus 3 gives you 0. So our answer is going to be x squared minus 4x plus 1. Okay, let's take a look at this one. Got x squared minus 9x minus 1 over x minus 2. And we want to divide using long division. So again, I'm going to set it up in appropriate form. We look at the first term of each, decide what to put up on top. We ask ourselves, what times x gives us x squared? And that'd be x. Now remember, whatever you put up on top, you multiply by what's out in front. So we're going to take x times x minus 2. X times x is x squared. X times negative 2 is negative 2x. So we got x squared minus 2x. We're going to subtract that line, which means we'll flip signs. So this becomes negative, and this becomes positive. X squared minus x squared drops away. Negative 9x plus 2x gives us negative 7x, and I'll bring down the minus 1. And again, we look at the first term of each, decide what to put up on top. You ask yourself, what times x gives you negative 7x, and that gives you negative 7. Whatever you put up on top, you multiply by what's out in front. So take negative 7 times x is negative 7x. Negative 7 times negative 2 is positive 14. Put that there. And we're going to subtract. Oh, I was listening to the message, see if my wife was stuck in the snow, see if I need to go get her. Blah, blah, blah. Okay. It's loud as can be. Okay, there it's done. Okay, so we're going to subtract this line, which means flip the signs. So the negative 7x becomes positive. The positive 14 becomes negative. Negative 7x plus 7x drops away. Negative 1 and negative 14 gives us negative 15. Now, the degree of what we're dividing by, the x minus 2, degree is the largest power of x. So degree of this is 1, and degree of this is 0. When your degree down here is less than what you're dividing by, that's your remainder. So our answer is going to be x minus 7 plus negative 15 over what we're dividing by, which is x minus 2. Now, if you want, you can put the negative out in front. You're probably going to find it's going to cause you less headaches if you just put negative up on top in the numerator. Because as your problems become more complex, you'll have different parts to it, besides just a single number. Let's take a look at another problem. Time for my tablet to blow up. Bring up another one. There we go. 3x to the fourth minus 2x plus 3x to the third minus 2 divided by x squared plus 3x minus 1. And still long division. So let's set in our form. So we got x squared plus 3x minus 1. And then we're going to have 3x to the fourth minus 2x plus 3x to the third minus 2. Now, in order to do the long division, these must be in standard form. Both of these. So that must be in standard form, and this must be in standard form. Now, standard form means you go from your largest power down to your smallest. So we'll have x squared plus 3x minus 1. And here our largest power is x to the fourth. The x to the third is next. So I'm going to have 3x to the third, the negative 2x, and then the minus 2. So that's in standard form. And for missing powers, we want to put 0 placeholders. So for missing powers, we want to put 0 placeholders. Well, this what's out in front here? We got x squared. This is x to the second power. This is x to the first, and this is no x. So we have everything there. So we got x squared plus 3x minus 1. Now what's inside starts with x to the fourth. So we have an x to the fourth. We have an x to the third. But I'm missing an x squared. So I'm going to put a 0x squared here. And then we have the x to the first, and then we have the no x at the end. That's what we mean by 0 placeholders. Now, some books teach us by telling you to put a blank space there. I think 0 placeholder to make sure everything's in the correct form. And you want that for not only what's inside here, but if there's any missing powers out in front here. You'll find that it works out best if you put it here also. Well, now we're ready to do our long division. Everything's in standard form, and we put 0 placeholders for missing powers. Well, we look at the first term of each. You ask yourself what times x squared gives you 3x to the fourth, and that would be 3x squared. Now, whatever you put up on top, you multiply by what's out in front. So we're going to take the 3x squared times x squared plus 3x minus 1. 3x squared times x squared gives us 3x to the fourth. 3x squared times 3x gives us 9x to the third. 3x squared times negative 1 gives us negative 3x squared. And let me write those down. Now we're going to subtract that, so we're going to flip the signs. The positive 3x to the fourth becomes negative. The positive 9x to the third becomes negative. the negative 3x squared becomes positive. Now 3x to the fourth minus 3x to the fourth drops away. 3x to the third minus 9x to the third gives us negative 6x to the third. 0x squared plus 3x squared. 0 plus 3 is 3. So we got 3x squared. And then I'll bring down everything else. Now, by putting the everything in standard form and putting 0 placeholders, what that ensures is that all the like terms are in the same column. See how the x to the fourths are in the same column, the x to the thirds, and the x squareds? It'll always work that way. Okay. Now we'll continue. You look at the first term of each, decide what to put up on top. You ask yourself what times x squared gives you negative 6x to the third, and that'd be negative 6x. Whatever you put up on top, you multiply by what's out in front. So we're going to take negative 6x times x squared plus 3x minus 1. Negative 6x times x squared gives us negative 6x to the third. Negative 6x times 3x gives us negative 18x squared. And negative 6x times negative 1 gives us a positive 6x. So let me put that here. Okay. Now we want to flip the signs. So this negative 6x to the third becomes positive. This negative 18x squared becomes positive. And this positive 6x becomes negative. Negative 6x to the third plus 6x to the third drops away. 3x squared plus 18x squared gives us 21x squared. Negative 2x minus 6x is negative 8x. And then I'll bring down the minus 2. Now again, we look at the first term of each, decide what to put up on top. We ask ourselves what times x squared gives you 21x squared. And that'd be 21. Whatever we put up on top, we multiply by what's out in front. We're going to take 21 times x squared plus 3x minus 1. 21 times x squared is 21x squared. 21 times 3 gives us 63x. 21 times negative 1 is negative 21. So we've got 21x squared plus 63x minus 21. We're going to subtract that line, which means flip signs. So this becomes negative, negative, positive. 21x squared minus 21x squared drops away. Negative 8x minus 63x gives us negative 71x. Negative 2 plus 21 gives us 19. Now, the degree of this was 2. Degree is the largest power of x. Degree of this is 1. Since the degree of this is now less, then this is our remainder. So we'll take the 3x squared minus 6x plus 21, and we're going to put our remainder over what we're dividing by. So negative 71x plus 19 over x squared plus 3x minus 1. And assuming no basic math error, then that would be our answer. Sometimes I add and subtract wrong or multiply wrong. Okay, let's look at synthetic division. We've got x squared minus 6x plus 8 over x minus 2. And this is synthetic division. Our first step of synthetic division is we take what we're dividing by and set it equal to 0 and solve. So we'll take the x minus 2, set it equal to 0 and solve. And we get x is equal to 2. Second thing, we want to set it up in this form. We put a box in the upper left hand corner, and whatever number we find right here, it automatically goes in this box. Now you identify your largest power of x. Our largest power of x is the second power. So I'm going to have, and I'll write this real small here. We're going to have an x squared, we'll have an x, and we'll have our no x. So you start with your largest power, and then you have them for each power going down. So x squared, x the first, and no x. Now you always want to make this really small. Do not make it big in any sense. I probably made it bigger than I normally would, just so you could see it in the video here. But these are just kind of a guide to make sure you put everything in standard form, you're not missing any powers. Well, now we want to write down a number that's in front of them. The number that's in front of our x squared is a 1. The number that's in front of our x is a negative 6. And our no x, our constant term, is the 8. Now we want to go through a series of adding, multiplying until we're done, repeating them. And I don't know how many we need. That's probably definitely enough. We start at the far left column here, and we're going to add 1 plus, we got nothing here. 1 plus nothing is 1, and put it there. Then we want to multiply. You always multiply by the number up in the box, by the number you just put down here. So 2 times 1 gives us 2. Then we want to add. Negative 6 plus 2 gives us negative 4. And then we want to multiply. You always multiply by the number up in the box, by the number you just put down there. 2 times negative 4 gives us negative 8. And then we want to add. 8 minus 8 is 0. We don't have to do these last two. Now this up here was x squared. This is going to be 1 degree lower. So this will be x. This will be our no x. This will be our remainder. So our answer is going to be x minus 4. Let's look at another synthetic division. I got x to the third minus 5x minus 2 over x plus 4. A lot of people don't like synthetic division until it clicks with them. Once it clicks with them, they love it. And they ask, well, can't we do synthetic division on everything? And I'll talk about it in a minute. When can you do it? Okay, we're going to take what we're dividing by, the x plus 4, and set it equal to 0 and solve. So take the 4 over and we get negative 4. Step 2, we want to put that negative 4 in a box in the upper left-hand corner. Now our largest power is x to the third. So real small here, I'm going to write x to the third, x squared, x, and no x. And I know that's kind of small, you probably can't see it. But x to the third, x squared, x, no x. Now the number that's in front of our x to the third is 1. We don't have an x squared, so we put a 0. So if you're missing any powers, you have to put a 0 there. Before the x is a negative 5, and our no x, our constant term, will be a negative 2. Now we want to go through a series of adding, multiplying over and over until we're done. I'll start at the far left here. 1 plus nothing is 1. Then we're going to multiply. You always multiply by the number up in the box, by the number you just put down here. Negative 4 times 1 gives us negative 4. Then we want to add. 0, negative 4 gives us negative 4. Then we want to multiply. You always multiply by a number up in the box, by a number you just put down there. Negative 4 times negative 4 is 16. Then we want to add. Negative 5 plus 16 gives us 11. Then we want to multiply. You always multiply by a number in the box, by a number you just put down there. Negative 4 times 11 is negative 44. And then we want to add. Negative 2 and negative 44 gives us negative 46. And this was x to the third. This is going to be 1 degree lower, so this will be our x squared. This will be our x. This will be our no x, or our constant term. And this will be our remainder. So we're going to be left with x squared minus 4x plus 11. And we'll take our remainder and put it over what we're dividing by, which is the x plus 4. And that's our answer. Let's take a look at one more of those. And then I'll talk about when can you use this. So we have x to the fourth. My wife's home. She's listening to the message. Plus 5. And then x minus 2. First step. Take what we're dividing by, set it equal to 0. So I set x minus 2 equal to 0, and we get x is equal to 2. Now step 2. Build our form. Whatever number we find in step 1, we put in a box in the upper left-hand corner. Our largest power of x is x to the fourth. So we're going to have an x to the fourth, we'll have an x to the third, we'll have an x squared, we'll have an x, and we'll have a no x, our constant term. Well, the number that's before our x to the fourth is 1. There is no x to the third, so that's 0. Numbers before x squared is -3. There is no x, so that's 0. And our no x, our constant term, is 5. Now this, again, what this ensures when you put it real small across the top here, it ensures that they're in the right order, standard form, largest power down to smallest, and you're not missing any powers. Well, now we want to go through a series of adding, multiplying over and over until we're done. Start at the far left column. 1 plus nothing's 1. Now we're going to multiply. You always multiply by number up in the box, by number you put down here. 2 times 1 is 2. Put it here. Then we want to add. 0 plus 2 is 2. Now multiply. You always multiply by number up in the box, by number you put down there. 2 times 2 is 4. Now we want to add. -3 plus 4 is 1. Now we want to multiply. Number up in the box by what we just put down there. 2 times 1 is 2. Add. 0 plus 2 is 2. Multiply. Number up in the box, which is 2, times 2 gives me 4. And then we'll add, which gives us 9. Now, this was x to the fourth. This is going to be 1 degree lower, so this will be x to the third. This will be x squared, x, no x, and our remainder. So our answer is going to be x to the third plus 2x squared plus x plus 2 plus our remainder over what we're dividing by. So we'll put the 9 over the x minus 2. And that's our answer. Okay. Again, once it clicks with you, you'll love it. You want to do everything with synthetic division. Up to that point, you may be like, no long division, I want to stick with it. Now, when can we use synthetic division? Can only use synthetic division when dividing assuming I can spell divide, when dividing by x plus a number or x minus a number. X minus 2, x plus 2. So only when it's in that form. If I had something that looked like this, where I was dividing by 2x minus 1, can't do it. It has to be just a single x plus a number. If I had x squared minus 3 like this, can't do that. It has to be x to the first power. So it is kind of limiting. You're sitting there, well, that seems like that cuts out quite a bit. And it does. But you'll find that place where you'll use this the most, for those stopping at college algebra, every problem you'll run across in college algebra, well, I shouldn't say every problem. Rational functions uses them for slant asymptotes, and you run across a few there, but most of them you run across in the entire course are of the form x plus a number, x minus a number. So you have to use it quite a bit, actually. And I believe that was the last problem. So let me go ahead and save this.